Hey, I'm Jeff. I'm an engineering manager on our vehicle perception team here at Wovin by Toyota. I mean, we're building autonomy functionality in such a way that we think we can expand capability over time. The way that I think of the role of my team is answering this question of where am I for the vehicle? I think there's two ways in which we answer this question. The first is in a relative sense, like where am I now relative to where I was previously, and how am I moving? How fast am I traveling? We call this the odometry system. And then the other way that we answer where am I is where am I in a map, and how does this map information, how can it augment other structure that I'm inferring about the environment? Like what's the speed limit on this road, and where am I along a route that I want to travel? I always enjoyed math, but engineering is a way to kind of ground math in real world problems, things that you can understand. And I've always loved working with sensor data because sensors magically kind of take real world information. What's like the light intensity off of the ground, or, some inertial signal like acceleration or angular rate, or position with respect to a constellation of satellites in outer space. You get to take all of these signals and fuse them together to get something that's actually meaningful to an algorithm. Toyota cares about safety and they care about craftsmanship, but I think that's actually pretty well aligned with like how I feel about how we should be rolling out this tech. We want to be careful of that. We want to be deliberate. Toyota's super complex. It's huge. Our production platform, we don't own it. We own one chunk next to dozens of other groups. And so it's, understanding how they play together and how to integrate it. It's definitely a different engineering skill set than, sitting down in Arene where you go software. For a vehicle to make a safe decision, like to center in the lane or to change lanes accurately, you need to know where the lanes are. In traditional AV systems, that information about lane geometry or lane topology, how lanes are connected, what traffic lights control which lanes, where there's a stop sign, how lanes are connected across intersections, all that information is embedded in an HD map. And the reason it's embedded in an HD map isn't because we like building maps. It's because this is a really hard scene understanding problem to solve. And what we can do is we can build a geometric map. We can send it to human annotators. They can mark up where there's lanes, where there's traffic lights, how those traffic lights are connected to the lanes, how lanes are connected across intersections. ML and AI over the last several years has moved so fast that now it is realistic to solve those problems online. And we don't have to keep maps up to date. We don't have to build maps everywhere. Honestly, I've been really excited to see the progress that we've made. I love building things. I'm an engineer because I want to build things. I want to take some math, I want to take some data, I want to, take some actuator and make something woo. I love working with people. We build a better system because we're a better team. Having a desire to want to build a cool system and then having a desire to want to build that as part of a team are probably the two attributes that I'd really like to encourage folks to bring here.